Okay, welcome to Chapter 5. In Chapter 5, we're going to be looking at three main ideas. The first idea is going to be graphing reciprocal functions. The second idea is going to be graphing rational functions. And then we're going to look at solving both equations and inequalities. So getting started on a reciprocal, we did look at reciprocals in grade 11 as well as in other topics like dividing fractions. First of all, to have a reciprocal, you have to have an original term. And then we can come up with the reciprocal. And most of the time we think of the reciprocal as the flip, which is not really a mathematical term. But we're going to take the original number 2, and the reciprocal will be 1/2. Or we could take the number -3/5, and the reciprocal would be -5/3. And so sometimes we think of the reciprocal as the fraction and the original as a non-fraction, but that's not true. I could also start with the original of -1/3, and then the reciprocal will be -3. What has to be true whenever I have an original and a reciprocal is if I were to multiply them together, I would always end up with an answer of 1. So 2 times 1/2 is 1, -3/5 times -5/3. If I multiply them together, it's going to turn into a positive, and then I'll get 15 over 15, which is the same as 1. And then same thing here, a negative times a negative is a positive, and 1/3 times 3 is 1. Okay, so the first thing we're going to do is investigate the graphs of reciprocal functions. So you can take a look at the first pair here. Our very first function, f of x equals x. That's just our parent function for a line. It's the line that goes through the origin on what we might think of as a 45-degree angle if our scales are matching. And then the first reciprocal is the parent function reciprocal from grade 11. And then we're going to look at a couple of different original functions with reciprocal. So here's just a more complicated line for the second original and then the reciprocal of that. And then here we're going to actually look at what happens when I have a quadratic as the original and I take the reciprocal of that. So our idea here, our goal is to connect those characteristics of the graph of f at x with the graph of 1 over f at x. So I want to figure out what the connections are, and I'm either looking at linear or quadratic, so that's a little bit new. So for this, I do want you to open up Desmos and play around with these graphs. I'm going to go through. If you want to pause now and do that, you can do that. When you type into Desmos, you do need to put the denominators of all of these things in brackets. Otherwise, you're only going to get the first term, or the first even number underneath the fraction. All right, so when I do this on Desmos, I'm going to graph the first pair together, the original and the reciprocal of that original, and then I'm going to go through the characteristics of each of those, or the properties. So I've got here just a picture of the first ones. So here I've got my f at x in red, and then in blue I've got the what we're calling g at x, the 1 over x. So I'm going to first just take a look at the f at x graph and come up with all of my properties for that graph. So the first thing it asks me for are there zeros or vertical asymptotes, and I do want you to state where are they. So I see on f at x there is a 0 at x equals 0. And then the second part here asks me for what are the intervals where the y values are positive and negative. So what I'm asking is where's the graph above the x-axis and below the x-axis. So here on my graph I can see that the red graph is above for any x value greater than 0. And it was below for any x value less than 0. And then looking for intervals of increase or decrease. When I look at the line, remember when we look for intervals of increase and decrease, we always start on the very left-hand side of the graph and then just tracing along to the right, asking ourselves, are we always going up or always going down or switching? And here I'm always going up on this graph. So there is an interval of increase. It's the entire domain of the function. And there are no intervals of decrease. Next, we're going to take a look at what are the x values when y is +1 or -1. So looking on my red graph, I'm going to y equals +1 and I'm finding the x value. It's 1. And then for the second one, I'm going to go find the y value of -1 and again sliding across until I hit the red graph and I see that the x value is also -1. And that's because we're looking at this basic function. So my x value is 1 and my x value is -1. The last property that they're looking for is what are the x values of the local minimums or local maximums. So on a line, I don't have any minimums or maximums. All right, now we're going to focus on the blue graph, the G at X graph. And again, the first question was asking us for what are the zeros or what are the vertical asymptotes. So there are no zeros here. This graph never crosses the x-axis. There's a horizontal asymptote here, which means that I get closer and closer and closer to that line, but I never touch it. But there is a vertical asymptote in the center of the graph at the x value of that line. All the points on that line, the x value is 0. So the x value, we'll move over to the blue pen. The x value is 0. And then we're going to look for what about the intervals where the y values are positive or the y values are negative. So again, looking for where's the graph above the x-axis. That's when x is greater than 0. And when is it below the y or the x-axis? That's when x is less than 0. Now we're looking for intervals of increase and decrease. Remember, I start on the very left-hand side of the graph and I'm just tracing along and asking myself, am I heading up or down? And as I trace along, I'm always heading down. Okay, so I'm heading down from negative infinity to 0. And then I restart and I'm heading down again as I trace along, and this time from 0 to positive infinity. Oh, sorry, I was heading down. Not up. I put that in the wrong spot. Negative infinity to 0 and 0 to infinity. And then, of course, there are no intervals of increase. I was never heading up to the right on the blue graph. Okay, next up we're going to look for the y values when, or sorry, the x values when y is 1 and y is negative 1. So I go to y equals 1 and I slide across until I hit the blue graph. It's at x equals 1. And then I'm going to go to y equals negative 1 y equals negative 1, scroll across until I hit my blue graph, and sliding up I can see that that's at x equals negative 1 as well. And then we're looking for values of local minimums or maximums on my blue graph. Again, there are no minimums or maximums. Here it goes up forever, so there's no maximum point. It goes down forever here, so no minimum point. All right, so next we're going to take a look at m at x and n at x. So now just a little bit more complicated line and the reciprocal of that line. So again, I've got a picture here of those two graphs, the line obviously in red, that was our m at x, and the reciprocal in blue. So first, taking a look at the line, we're going to look for what are the x-intercepts or vertical asymptotes. So along this line here, I can see that the x-intercept happens at positive 1/2. And now we're looking for where is the graph above or below the x-axis. So the y values are positive everywhere less than 1/2. For everywhere less than x is 1/2. And then again, the y values are negative after that. So when x is less than 1/2, the y's are positive, and when x is bigger than 1/2, the y's are negative. Then intervals of increase and decrease. Along this line, the red line, it's always decreasing. And there are no intervals of increase. Remember, we are looking for relationships between the red columns here and the blue. We're trying to find some patterns so that we can make some predictions about what our new reciprocals are going to look like. So next I'm looking at the y values. When the y value is 1 on the red graph, the x value is 0. And then when the y value is negative 1, the x value is positive. And now we're looking for those minimums and maximums, and of course we're looking at a line, so there are none. Okay. So hopefully we're seeing some connections here between the first pair and now this new pair. I'm going to switch over to looking at my blue graph now and looking for the vertical asymptote. I notice that it does actually pass through where the x-intercept was on the original function. So what we see here is this connection between the x-intercepts of the original and the vertical asymptotes on the reciprocal. Okay, next up we're going to look at the y values being positive or negative. Again, here the y values of the blue graph are positive or above the x-axis at the same time as the red graph, and then the y values are negative or below the x-axis at the same time as the red graph. So I'm also seeing that connection there. Oops. Okay, so next we're looking at intervals of increase and decrease. On the blue graph again, starting on the left and scrolling around, I see that I'm always increasing until I get to that vertical asymptote, and then always increasing in the second piece as well. So here it looks like there's a switch, right? Where I was decreasing on the first, I ended up increasing on the second. And that same switch is going to happen here. I was increasing nowhere, so now I will be decreasing nowhere. There is a connection between the intervals of increase here. It was everywhere on the domain, and now I'm decreasing everywhere on the domain. So I just have to skip over that vertical asymptote. All right, next we're looking at the y values, and hopefully that you notice that every time that I have these two graphs, what's happening is that they're crossing each other when the y value is 1, and then they're crossing each other when the y value is -1. So they're crossing each other when the y value is 1, and they're crossing each other when the y value is -1. And that's why these are important values for me to take a look at. All right, the next one we're looking at is local minimums and maximums. And again, this reciprocal graph does not have any minimums or maximums. So we're still not quite sure what the connection is there. We've got the connection between all these other pieces. And again, here we're seeing that these guys go straight across. There is a connection between those points. All right, so last pair we're going to take a look at. This one's going to be a little bit different because we're starting with a quadratic or a parabola here, and then we're going to look at the reciprocal. So you're going to type those both into Desmos, and I do need Desmos to come up with some of my values for this one. So I'm going to kind of be pulling them out of thin air, but I did actually take a look on Desmos for those values. So here's a picture of what those two graphs look like. And so first I'm just focusing on the red graph. So my red graph is called P at X. That's my regular parabola up there. And I'm looking for first the x-intercepts or the vertical asymptotes. There are no vertical asymptotes, but two x-intercepts. And then the next thing I'm looking for is where is this graph positive? Below x is -3 and above x is 0, and then between -3 and 1, or between -3 and 0, I can see that the graph is negative. Oops, 0. All right, so next we're looking at intervals of increase and decrease, and we're going to see some of both for a parabola, right? Again, I'm starting on the left-hand side and sliding along my graph, and first I'm decreasing, and I continue to decrease until I get to this vertex of the parabola, which is going to be at -3/2. So I'm decreasing from -infinity to -3/2. And then after that, I'm increasing. Notice that I'm not using a square bracket on the vertex because I'm not increasing or decreasing at that point. It is a flat point on the graph, neither up nor down. Next, I'm looking for what's going on at y equals 1 and -1. So this is where I had to use Desmos to come up with the values here. So this one here is about -3.3, and this one here is about +0.3. And then looking for where's my graph across from y equals -1. So here's the point here, and here's the point here. And again, I use Desmos for this to come up with the values -2.6 and -0.4. So I've got my values for those. Now I'm looking for maximums and minimums. So this parabola has a minimum, and the minimum is at x equals -3/2, and there is no maximum. So now we're going to take a look at the reciprocal. So we're focusing now on the blue graph. The blue graph is called Q at X. And it kind of disappears here. It's just because the line got too steep for the program to draw it. the first thing that we're looking for are vertical asymptotes or x-intercepts. So this graph has two vertical asymptotes. I can see there's one here at -3 where the graph is getting really, really close to that line on above and below. And then there's another one at 0. This is not surprising for us, right? Because we already kind of predicted this relationship over here with the line. So it holds still for the parabolas. Next, take a look at the intervals where the y values are positive and negative. So again, looking at my blue graph, I'm above the y-axis in the same sections where my red graph was above the y-axis. And then my blue graph is below and my red graph is below. So you want to think about, like, well, why does that make sense with the algebra? Always trying to connect the graphing with the algebra. So it makes sense, first of all, looking at zeros and vertical asymptotes, it makes sense that these things are connected to each other because I'm talking about what would make this thing equal 0, what would make p at x equal to 0. Well, then I would have 1 over 0 over here, and you can't divide by 0, so this can't exist when the bottom equals 0. So it makes sense that those things are connected. And then the next piece, where are the y values positive? Well, if I pick an x number here that makes this answer positive, then over here I'm going to have 1 divided by a positive number, which will still be positive. So that makes sense that these guys also connect to each other. Same thing if this guy, if I plugged in an x number that made this answer negative, then over here I would have 1 divided by that negative answer. So that would also be negative. So it makes sense that these guys are also the same. X values would make these two answers negative. All right, intervals of increase and decrease. So for the blue graph, what I see is I start off increasing, and then I flip over the vertical asymptote, and I'm still increasing until I get, again, to -3/2. So my intervals of increase here are -infinity, and I have to pause at that -3 asymptote, and then after that asymptote, it's still increasing until -3/2. After that, at -3/2, I start to decrease, and I'm decreasing until I get to 0, and then I hop over that 0 asymptote, and I'm still decreasing. And so here we see a switch. I know it's not a direct switch because the asymptotes got added in, but otherwise it is a switch because between intervals of increase and intervals of decrease. And so let's talk about the algebra behind that. Why does that make sense? Well, if the answer to the p at x's are getting bigger and bigger and bigger, so let's say they're increasing, then that means that over here I'm getting a bigger and bigger denominator. So it's like going from a half to a third to a quarter to a fifth, and I'm going to continue to get smaller answers over here as the denominator gets bigger. So as this thing increases, this will decrease. And then the opposite is also true. If this is getting smaller and smaller, then over here I'm getting 1 over a smaller and smaller number. That's actually going to make the total answer bigger. It'd be like going from 1/10 to 1/8 to 1/6 to 1/4 to 1/2. These things are getting bigger in value, and so I'm going to be increasing. All right. Back to our graph, we're looking for the x value when the y values are 1, and hopefully you notice that again those are intersection points, and also at -1 I also have intersection points between the original graph, the red, and the blue graph. Those are the only points where those graphs cross each other. And then again you can take a look at the algebra behind why does that make sense. Well, I'm going to use some simpler values over here. So let's say I take x equals 0, and I'm going to go back to this example here. Then I plug in and I get the answer +1. Well, when I take that x equals 0 and I plug it in over here, because it's the same thing, I'm going to get +1 on the bottom. And then I get 1 divided by 1, which also gives me the answer 1. Over here, if I plug in a number and I get -1 for the answer, then over here I will also get -1 for the answer because I'll have 1 divided by -1. So those guys are always going to be the matching. And it depends on the answers, right? It depends on the y values. Don't get that mixed up. All right, so finally a parabola, we had a minimum on our original graph. What happens on our reciprocal? Well, we actually end up with a maximum there. So the maximum ends up at -3/2. And I want you to just take a look at the y values of those two answers. The minimum y value is down here, and the minimum is or sorry, the maximum now is higher. So thinking about, well, what is happening to that value? And I'm just gonna pretend that it's a nice value for a second here. So let's pretend that the original graph p at x had a minimum value at -2. Instead, I know it's -2 point something something, but I don't have that number right in front of me. Well, then what would be happening on q at x? Well, it would be 1 over that value, -2. So the minimum or the maximum value, sorry, would be at -0.5 on that graph. So you kind of see that it's a little bit higher than that. But those two values, the y values, are also related. Don't forget that all of those y values are reciprocals of each other. And I could actually play that game with any point on the graph. So no matter which value I pick, so let's say I randomly picked this point here on the original graph. So when x equals 1, I got a height of 4. Well, then on the new graph, I will have, when x equals 1, I have a height of 1/4 because it's the reciprocal of the y values. So I can always find those new points pretty quickly. Also, what you should notice is that on the red graphs, as they get really, really big, so as this went from 1/4, if it went up to like say 8 or 100, the y values on the blue graph are going to be getting really, really small, right? Because then instead of 100, so let's say I had a point up here, let's do a dot, 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 because we're going to be missing a few. So let's say on p at x I had like 1 and 100. Well, then on the reciprocal graph down here, I would have like 1 and 1 over 100. So it'd be really, really small. So I noticed that there's a pattern between really big values and really small values. And the opposite's also true. If on the p graph, on the red graph, I looked first at a really, really small value. So here would be like here I would at like -3 point something. And I don't want to go -3 exactly, sorry. Let's go with -2.99 or something like that. The y value would be -0 point, or let's even go with a fraction. So it's easy to think about. It'd be like -1 over 1,000. Well, then on the reciprocal graph, the y value at the same x value, the y value would now be -1,000. So it'd be a really big negative. So I'm going to find that pattern as well. All right, I'm going to end this video and then we're going to summarize in our lesson.